Okay, so let us see how do we actually configure. So let's go back here. So then we're gonna include the data directive to store data or string at program memory. So we're going to use db. So let's say we're going to store this series of value. So now, when we want to actually configure the table pointer to point to the first address, now there is an issue here. The earlier example, we have seen that we know the address of these values. But now when we do the programming, it's quite difficult for us to know where is the address. Of course, you can view it, but we are going to write some programs here, right? Some instructions. So there are a few ways you can actually do. One is you can actually use origin. So let's say if you set origin 3000. Oh, sorry, 3000 is too big. Here, 30. Yeah. So if you do this, then if you let me save this as so it would be table pointer. So if we build this table pointer, this code, and if we view the program memory, let me just rearrange this back. So you can see that you know why we are starting at 001A, why is your start at 001A? Because the last RETFIE is stored at 0018 and 19, right? That's part of the program start template. But then look at X30. This is where you have the data 45672167, right? So if you are using origin like this, then of course your configuration is easy. That means what you do, if you want your pointer to point to the first address, the first data, so what should be the address that we want to load into the table pointer? 30. Are you understanding what I'm asking? Yes. Why we want to check the data memory? This one? It won't. This won't be stored in data memory. So empty. It's not possible it's be stored there. So do you understand this part? What are we doing here? This segment here. Guys, it's a question. We are storing the data, right? We're using DB. So which address is the starting address? 0030. So you can see here at address 0030 you have 45. Where is 67 stored? 31. Where is 21 stored? 32. Where is 67 stored? Is that clear? So you know the data are stored there. Now you want to configure the pointer to point to the first address of the data. What is the first address of the data? X30. So what should be the value that you want to configure or load into the table pointer? 35. Why 45? 45 is the data. Table pointer will point to the address. So which address again? So that means table pointer low, you should load what? 30. Table pointer high? Table pointer upper? Very good. Some improvement of that. So hex 30. And you move it to table pointer low. Then I think we can just clear F, table pointer high, and clear F, table pointer upper. Is that clear? After configure, what we want to do? We want to read, right? So we can use table read asterisk. So let's see if we use asterisk, what happens. So you all know what's going to happen. You'll end up reading the same value. But let's take, for the sake of fun, let's try to do it. Okay, so we have built. So let's go to the simulation mode. And you can press F6. Okay, let us also monitor the special function register. So maybe we can, we'll watch. We'll move this a bit up. Okay, for the watch, if you see on table pointer, table pointer high, table pointer low, and table pointer upper. So just use the R, it'll straight away show you the entire content of table pointer. And then we also want to include table latch. So let's include that. So keep it down here. Are you able to see? So go back here, F7. So you see when you load the value, so only the first time when we load the value, it becomes red in color. Then when you clear F and clear F, why is not changing color? Because the value is not changed. It still maintains 0, so that's why it's not changing color. So now we're going to use the table read. So when you use the table, So which value it read? 45 into table latch. Of course, here I didn't put something to prevent the data from going down. So what I can do here is I can put branch repeat, and I can put repeat here. So if we build this again, so once this is configured, you'll see it'll read, table read. Then if you read again, there's no change. Why? Why? Do you see the table pointer is same? That is because we're using table read asterisk. So we have to put table asterisk plus. So then if we build this again, now let us see. Okay, now we have configured it's 30. So table read, do you see after the table read, do you see the content of table pointer increases by 1? So when you read, you read 67. Then you read 21. Then read 67 again. Then of course you're reading FF because it's keep on reading the next line. There's one problem here. There are two problems here in this code. Can anyone tell what is it? We just saw one problem just now. Two problems also we saw just now. It doesn't stop, that is one. So what you can do to make it stop? Put the finite loop. Put the table read within a finite loop. So how many times you want it to loop? 4. Why? Your 4 values, right? So sandwich it. I showed you the easiest way of doing that, right? So how can we do that? Let's try to do here. So let's say, let's move this down. So we have, let's say we have our assembler directives here. So we can have loop count. We want to assign an address to this, right? To loop count. So maybe we can choose hex 00 and loop limit. We can is a value. So 4. So what we can do? We can move the loop limit into working register, and then we move it to loop count. And then what do we do here? Decrease file register, skip if 0. So what are we decreasing? Loop count, and each time we decrease, we want to store it back. So this will skip if it's 0. So then it will go out. If it's not 0, it won't skip, so it will do branch repeat. Right? So this part is settled, right? If it's not 0, it will repeat. But once it's done, you need to branch. Why do we need to do this? Yes, to prevent it to continue to execute this part. Like just now, you see, I didn't put it continue when to 45. The PC will go there. So we want the PC to just get stuck here. So let's try this then. So you have solved one problem, there's another one. Okay, let's see. So if loaded, so managed to get 67, 21, 67, and then out. So all the 4 values it managed to read. Okay, good. You have solved. Then, of course, because we put this, it always gets stuck here. You have solved the first problem. What is the second one? Yes. The data is kept on being displayed at table latch. Then the next data overrides the first data. So there's a problem here, right? So you need to store it somewhere else. For example, you can store it in data memory. So here, remember, whenever you have a series of arrays in program memory that you want to read, you have to use table pointer. So if you want to copy a certain data here to a certain data in data memory, also in a form of array, what do you think you should use there? Couldn't understand the question. Okay, now in program memory you have an array of data. You want to copy this array of data using a pointer, and you're using the table pointer asterisk plus. So we want to copy that to data memory. So here, if you're using pointer, what do you think that we should use at data memory? FSR, very good. So which means now we need to initialize the FSR, right? So let's say we can just initialize it here. So maybe we can initialize, let's say we use FSR, 0, and we want to load hex 100, for example. So each time whenever your table read, so what you should do here? Should include a line, right, before you decrease. So what you should do, you should move FF from table latch to. So now here we have a series of data that we want to copy. There also we have a series of data we want to copy. So definitely we have to use post increment 0. Is that clear? Any question up to this point? So let us view so this is 100. Okay, this is 100. So let's build. Okay, let's build this. Oh, okay, there's another problem here. So I'm receiving an error here, overwriting previous address content, hex 30. So what happened here is, when I keep on adding all this instruction, it actually overlaps with hex 30. So meaning to say I have written more, all this instruction is saved from 1A until 1 hex 30 onwards. So it's actually failing to write. So let's say if we change this to 40. Later there's also another solution for this, but since we don't have. Come again? Okay, thank you for that. So let us build this. Okay, so let's view file register 100. Okay, so let's. Okay, we have initialized FSR. We'll initialize the table pointer as well. So now we're going to read. So it says 45. Now it's in table latch. You move it from table latch into 100. Okay, again. Then you can see 67. You move 67. Then 21. Then 67. Then out. So this is how we can actually do that. Now there is another thing. Okay, since we are running out of time, we'll actually very quickly continue this next week. But you can already start working on your assignments already.